Good morning, everyone. Happy Friday. Let's get logistics out of the way before we dive into today's lecture. I want to talk about a couple of things. The first one being the grade redistribution, which we have done. I'm sure most of you would have seen my email regarding that. Even if you don't understand all aspects of the redistribution, let me give you a high level overview of what has changed. So Mike and I wanted to drop the percentage allocated for exam 2 and also reduce the percentage allocated to final exams slightly. So obviously we had to redistribute the dropped percentage into all other components of this course. So instead of increasing the weight for exam 1 while doing the redistribution, what we've done is we've taken the amount of percentage that was supposed to increase for exam 1, and we are giving that as free points to the whole class. Hopefully, this redistribution has eased your pressure in this course and you feel good about it. The second thing which I wanted to discuss is about the final project itself. So, we are hoping to release the final project sometime tomorrow or worst case by Sunday. Just like exam 1, I'm going through the final project from scratch, pretending to be a student. Hopefully, that will give me a sense of whether the questions are too easy or too difficult. And hopefully, I'll be able to get through that over the day today, and we can release the project sometime tomorrow. So the due date for the project will depend on when we actually release the project. We'll be including that information as well. All right. Let's actually dive into today's lecture topic, which is going to be a continuation of, excuse me, of plotting topic that we started during Monday's lecture. So I hope most of you were able to go through the reading for plotting from Monday's lecture, either through the HTML file or directly through the notebook, raw notebook version. There is another reading for today's lecture, which is again like both HTML version and the raw notebook version, both prepared by Tyler. All right. So let me actually mention a couple of things. These links wouldn't work now. I'll be updating them once I upload this lecture, which I'm currently recording. The code link, on the other hand, will work. So if you go to the code link, you'll see a couple of notebook files. The first one that I want to talk about is the template notebook file. So I'm following this wonderful idea which Mike came up with, where like he added a bunch of markdown cells by adding a few questions. So I'll show you how to add a markdown cell today. So what we'll be doing is we'll be using this template and going through the lecture demo for today's lecture. And couple of other data files that we are going to be using is we are going to be continuing the scatter plot on trees.txt, and we are also going to be needing some data from snippets, hyphen line, and bar.txt, and then we'll also be reading the SP500 CSV file. All right, what I'm going to do is I have all of my files here. So this version is just a copy of my template notebook file for now, but I'll be uploading the completed version once I upload this lecture. So let's actually get started by running this. Before that, let me actually show you how to create a markdown cell. So creating a markdown cell is very easy. You just need to add a specific number of hashes in front of the text that you're trying to, add as a markdown in your notebook. So one hash means that your text will be really big. Two hashes means it will be a little bit smaller, and then so on. So once you add this content, you need to go to cell and cell type and mention that it's markdown. I've already done that for this particular cell, and then if you go ahead and run it, it will create a markdown cell for you over here. All right. So let me actually get started by running the initial cell, which is going to convert some of this text into red highlighted text. All right. I have all of the imports which I used as part of the previous lecture in here, and I just like dumped it into one particular cell. Recall that you need to mention matplotlib inline to be able to display the very first plot inline, which is like within this notebook, as opposed to opening it in a different window or saving it in a different file, for instance. One thing which I probably didn't mention during the last lecture is it's actually recommended to, not recommended, it's needed that you run the cell with matplotlib inline first before you vary any of the RC params. Recall that RC params is this dictionary which matplotlib offers in order to control some parameters for your plot, and we just saw how to reset the font size last time. So last time actually I went back and added import, I mean changed RC params way up in the notebook file. What I should have actually done is like added the RC params change like below whenever I spoke about it. So that's something that you need to actually correct from last lecture's notebook. All right, let's do a quick recap of bar plot from last lecture. So the question which I have here is, how do you plot a bar chart from pandas series? So recall that you will be plotting bar chart using series with series.plot.bar, where you'll be replacing series with a variable name which you have for the series. All right, let's look at the next question, which is like, what are the axes for the bar chart? So recall that series has only two different set of variables that you can control. One is the index and other is the actual values itself given by the series. So your index is going to be your x-axis in your bar chart, and your value is going to be the y-axis. So pretty much that's all you can control with respect to the bar chart, only like two different variables. So let me actually quickly motivate why we need scatter plot one more time. So as I just now mentioned, bar chart and pie chart will enable you to only visualize relationship between two different variables, one being the index and other being the actual value itself. What if you wanted to visualize the relationship between multiple variables, and you want to know how one varies with respect to the variation of the other? Then in such a case you would need to go with a scatter plot. And recall that we had this list of dictionary custom generated data set on trees, which had like which has few parameters. So essentially this data set is trying to talk about how much each tree ages, and of course like how the height and diameter increases as the tree grows, right? So typically it's just assumed that the tree will grow taller and wider with every year that the tree grows. All right. So one other thing that I want to do a quick recap on: whenever you have a list of dictionaries, you can easily convert that into a data frame, which is what we did during last lecture. As you can see, you had this really neat data frame. What if you want to visualize two different variables which are age and height? So typically what you'll do with a scatter plot is that you'll define a x-axis variable name, which is going to be given by the column name in the data frame, and the y-axis is going to be given by another variable. So recall that we used age for x-axis because age is supposed to be a time-based parameter. Time always goes on x-axis. And then we used height for y-axis to generate this plot, right? So take a look at this plot here for a minute and try to answer the next question in the template notebook, which talks about what are some aspects of scatter plots in general that you can control with different variables. So clearly, I told you that x-axis and y-axis can be controlled by mentioning variables from your data frame, right? Look at the plot and come up with other options over here. So I have a list typed out for you, which includes you have these points that get plotted as part of scatter plot, right? You can control color of the points, and you could possibly control size of the points, and you could also potentially control shape of the points, right? So let's actually discuss. Let me edit this markdown. Let's discuss how we can vary these aspects of the plot for this particular example. So clearly x-axis is going to be age and y-axis is going to be height. It's just so intuitive to have y-axis as height because height of the tree increases vertically and your y-axis is vertical. Makes so much intuitive sense with respect to this plot. So let me see here. The next thing that you can, next variable that you can use over here is the diameter variable, right? And then you have like three different aspects of the plot here which you can possibly consider for using the diameter variable. Think about this question here for a minute. Which out of options 3, 4, and 5 do you think can intuitively represent diameter? So if you're thinking of the size, that would be the closest parameter, that aspect that you can control with the diameter. Why is that so? You can just display the size of the dots to represent the cross section of the tree that you're talking about, right? So of course I'm going to show you how to vary the color and the shape of the points as an example. But then for the final solution, we are going to focus on varying just the size of the plot, and I will actually show you examples of other aspects as well. All right, so let's actually get started with how to vary color of the plot points. So let me actually go back and copy this plot line over here, which I'm going to keep using over and over again. So the way that you can mention color is, recall that you have a parameter called color, which takes either a string or a letter or a number. I'm just going to use R as an example over here. There we have it. We have red color points now. All right. So the next question here is asking, how do you vary the size of the plot points? This is not something that we have done in the previous lecture. So the size size parameter is going to be called S. And of course, you can pass an integer to that parameter. So let me show you what happens if you have size 100. As you can see clearly, the plot points are much bigger, and if you have let's say size 1, they're like so much smaller. So I'm going to leave this at size 100. All right, the next question here is asking, how do you vary the shape of the plot points? This is again one other parameter which we haven't discussed so far. So the shape can be mentioned using a parameter called marker. So marker is going to be the keyword term that everybody uses when it comes to plotting the plot points. So you can mention marker using various symbols. So you can use O for circle, which is not going to make any difference because we had circle previously. And then you can use plus for you can't really see that, can you? So let me actually increase the size over here. Hopefully plus is working. Yeah, there we go. So you can use plus, and you can use something which is called as the caret symbol, which is going to create like triangle shapes, and you can explore various options with marker points by doing a quick Google search of what set of markers can you use in Matplotlib. All right, that has to do with introducing all of these parameters for each of those aspects. Let's now discuss how do we actually take this knowledge that we just gained into answering this question. How do we add the tree diameter data to our scatter plot over here? So as I mentioned before, your size is going to be the best variable for representing the diameter, because you can talk about cross section. So recall that size is given by parameter s. So one thing that I want to show you is, if you give your data frame column name here for the size, which is going to be diameter, this is actually going to throw an error, because somehow the folks who wrote the code for scatter plot function decided that here they need to have series instead of a data frame column name. That's unfortunate. So this doesn't work because size parameter expects a series instead of data frame column name. Alright, that's a weird thing. Let me actually show you what does work. So recall that you can very easily create a series from a data frame by just extracting that column. So I'm going to say df of diameter, and let's see what that looks like. Alright, there you have the plot. So what's sad about this plot is there is actually size variation in the plot points with respect to the actual diameter, but then you can barely see it, right? So let's fix that. So let me quickly do a df dot head. So as you can see, the diameter is having a really small size. So the size of this dot is controlled by something which is called as the pixel size. If you're into graphics, then you'd probably want to dig into more details about pixel size here. All right. So what we are going to do, instead of having this really small value, is we can actually multiply diameter by a factor to make it much bigger, right? So let's say that I'm going to multiply the diameter by a factor of 25. As you can see, that's much bigger now than before. Let's try to include that in our plot. So we can simply say your size is going to be given by df of diameter into 25. There we have it. We have a much better plot. As you can see, some of these dots are smaller than the other plot points, other markers over here. All right. So I'm going to actually show you one other aspect that you can potentially control other than the size, but I'm going to caution you against doing this in general in plots. I'm going to actually use the diameter variable to control two aspects of the plot. The first one being the size of the markers, and the next one being the actual color of the markers. So it's in general not recommended to have same variable represent multiple aspects of the plot. So I'm going to actually type that here. Don't use the same variables to represent multiple aspects of the plot. That's a warning for you. So this is going to be dummy example. All right. So let me show you how you can actually set the color over here. So I'm going to, since this line is becoming much longer, I'm going to just hit enter and type the next parameter into a new line. You are always welcome to do that. So there we have it. I now added a color column. So one thing that you'll see here is, since we are using a floating point value from the data frame, you're going to have a grayscale variation here. If you want to use color palette instead, you have to mention a custom list that you create for like each possible value of your diameter. You need to mention one color value. I'm not going to do that. You can experiment with that. So what are the downsides of this plot? One thing here that you'll notice is some of these points are actually fully white. That's because the color palette is taking the minimum value of your actually the maximum value of your diameter, and setting that as white, right? We don't really want that, so we want to be able to control what color is represented by the minimum point over here with respect to the diameter. And I'm going to introduce you to a parameter called vmin that is going to help you control how you can actually display the white colored points over here. So vmin is sort of going to take some floating point value, because we are having floating point in our diameter column. So how do you actually assign the value to vmin is, clearly we need the minimum value from this particular diameter column, right? Wait, I'm switching back and forth here between minimum and maximum for white. Minimum is actually white, so we want to be able to fix that. So recall that you can quite easily take minimum from a column by calling the min function. All that you need to do is you need to be able to mention a different color for a minimum. For instance, you can just like say subtract 2 over here. I know that that's going to work for this plot because I did experiment with this number before I did this demo. But when you're doing it from scratch, you need to play around with this number to see how you can actually change it. So let me actually switch back and forth from the plot up here and down here. As you can see, the tree of age 1 is now displaying properly than before, where you couldn't see actually one of those tree entries way down here, which had like a height of 1.5. All right. Hopefully, this example made sense. So, just to do a quick recap, scatter plot enables you to visualize how two different variables vary with respect to one another. Clearly, as age increases, typically height of the tree does increase, right? Of course, there are cases where the increase in height is minimal. That could be a different type of tree that we are talking about. All right, let's move on to the next example here. The next example is also going to be about scatter plots. So I'm going to show you something which is called as the iris dataset. So this is a dataset which is typically used in the machine learning world. So if you click on the dataset link, it will take you to the page about the dataset. So if you don't know what iris is actually a flower. So what this particular dataset offers is like for different types of these flowers. It talks about the sepal length, sepal width, and petal length and petal width. And it also has various classes for iris, which in this particular case, there are three different classes for iris. The scientific name for it, for those classes, are given over here. All right. So what are we going to do with this data set is how can we create a scatter plot that enables us to visualize various classes in this particular data set. So let me actually go ahead and read the CSV for this data set. So recall that you can directly read the CSV file from the URL, provided that you have the correct URL over here. So there is going to be a data folder as part of this URL which you can actually use. So the actual data is inside iris.data. If you click on that, that will actually download a local version. What we want instead is we want to be able to read the data from the URL directly. So let me go ahead and do that. So I'm going to be reading that into a variable called df again. So we want to use the pandas read CSV function, and instead of mentioning a CSV file name, we want to directly read iris.data file from this particular URL, right? So let me go ahead and do a head of the data frame. Uh, there we have it. So what is weird about this data frame is that you'll see that the header line is actually a data line. That's because they don't have the header explicitly defined for this data set, unfortunately. So we are going to have to define the header on our own. So uh, recall that you can define your own header by using a parameter name called names, which takes a list of all the list of strings which represent the header name for each column. So you can go back to the description page here again to figure out what those columns are. I do know what those columns are, so I'm going to just directly type those. So the first column is going to represent sepal length, and the next column is going to represent sepal width. The next after that is going to be petal length, and then the next after that is going to be petal width, and the final column is going to be representing class. So I'm just using shorter names here instead of typing the whole thing. All right, there we have it. Much better now, right? So that particular data line is now the first line in your data frame. Let's actually take a look at the tail of this data frame as well. We always keep doing the head, right? So we want to be able to see if there is any variation in class over here, because clearly all first five entries belong to Iris Setosa class. So there we have it. So the tail actually shows entries for Iris Virginica class. Yeah, hopefully I pronounced that correctly. All right. So now that we have loaded the data frame, recall that the question which we are trying to answer is how do we create a scatter plot for various class types over here. Let me actually copy the scatter plot line from the previous example so that I don't have to type everything. So what are we trying to achieve here is we first want to get the set of classes that we are trying to plot over here, right? So your data frame column class is going to give you the various classes that you have. So what we want to do is we want to take the unique entries from in here and put it into another variable so that we can control the plot just using those three particular classes, right? So you can very easily convert your series that you extract out of your data frame column into a set by just like saying set of that. So as you can see, I essentially typed out that to store it into a variable called class, because I want you to see that class is actually a keyword in Python. So as we have given you direction before, you're not supposed to use keyword names as variables. So we are not going to cover what a class is as part of this class. If you're interested, you can poke around a little bit and learn more about it. So I'm going to name my variable as classes, and let's actually see what is there inside classes. There we have it. We have three different class names over here. So do not get confused with this curly brackets and think this is a dictionary. Recall that sets also use curly braces as a representation. All right. So now we need to be able to visualize part of the data frame which is represented by one of these classes, right? So how do you do that? So we can very easily extract that part of the data frame by saying df of class is something. So I'm going to actually go ahead and copy the class name for the middle class over here, just as an example. So if you do this, this is going to, what did I miss over here? Oh, I'm missing the double equal to. I'm trying to assign instead of saying give me the data for this particular type of class. There we have it. So that's the subset of the data frame which is going to represent the iris versicolor type of iris flowers. So once you have part of the data frame that you're interested in plotting, you can very easily say plot dot scatter. Looks like I had that in my I had copied it earlier, but I replaced that with the class name when I copied that. So what we want to plot is we want some value for the x axis and some value for the y axis. So I'm going to say x here is going to be petal width and y here is going to be petal length. Of course, feel free to play around with other combinations over here. So, oh, I'm missing the comma. There we have it. All right. So as you can see, this does display, the relationship between petal width and petal length for the subset of your iris data set for this particular class over here, right? So this doesn't really answer our original question, which is like, how can we create a scatter plot for various class types, right? That means that your plot should include three different types of plot points for those three different classes. So let me actually show you how to switch this over. Since we are trying to vary this particular, the variety that we are trying to change within the plot, you can very simply use a for loop to loop over each of those varieties, right? So you can say, since classes is a set, recall that it's actually iterable. So you can say for variety in classes, do something, and that something is going to be clearly you want to do the plotting, right? So and then of course you want to replace this the not the assignment, sorry, the comparison check with the current variety. So let me go ahead and run this. So as you can see, when you run it, you'll actually get three different plots, which is not very useful, right? Of course, like you can say, okay, within the first class, okay, here is the relationship, and within the second class, here is the relationship, and similarly with the third class. What is so difficult to visualize all three classes here together, not visualize, to read all three classes here together from three different plots, is that your x-axis is actually entirely different for each of these plots. So it's not very easy to even like scroll down like this and compare, right? So let me show you how you can actually fix that. So I already have a note in my template for that particular change that we are going to make. So recall that your axis plot is a parameter that you can control as part of your plot function. So there are going to be a bunch of rules about axis plot parameter. So if you do pass an axis plot parameter, then the plot is actually added within the same plot that you actually pass. Whereas if you pass none to it, then Matplotlib knows to create a brand new axis subplot. And then every time you're going to create, call your plot function, it is always going to return your axis subplot that was used for that particular plot function. So let's actually control that. What we want to do is we want to be able to capture the return value given by this scatter plot function into a variable, right? So I'm going to initially define a variable called plot area, and I'm going to say that is none. So what we want to pass with the very first iteration of your loop over here is this none value, so which is going to be taken care of because we are initializing none. What we want for further iterations is we want the axis subplot which was generated for the very first plot, which is going to be a return value. So I'm going to capture that into the same variable name. So why am I doing that? That's because I'm passing that variable name as part of your AX parameter. Sorry, I missed the keyword name here, AX equal to for that particular parameter. Since we are passing that particular variable as a parameter, the next time you step through your loop iteration, your plot area is now going to come from the very first time that you created a scatter plot with. Hopefully that makes sense. Try to play around by not mentioning this, and try to understand why this is actually working. Let me go ahead and show you that. There we have it. Now we have like a better plot than before. We have like all of the plot points in the same plot over here. So what is missing is, oh, clearly I didn't actually I'm missing something with respect to the figure size. I'll fix that when I actually release the notebook. Hopefully you can still see it. What is missing here is all the points are getting plotted using a single color and using the same marker, right? So let's go ahead and fix that. I'm going to fix the color first. So as I mentioned with the previous example, let's say that if you want to use a color palette instead of using black and white grayscale, you need to define, you know, a list of colors. I'm just going to define the list of colors as blue, green and black here for each of those classes. So keep in mind that whenever you're plotting, you need to know how many different types of colors or markers your plot actually needs. Hopefully that will be finite for all the examples that you're trying. If you do have like too many types of classes as part of your data set, you need to figure out a way to control this color using a better approach than have a list of variables here. I have had to do that in some of my research plots actually. So I'm not going to talk about that, but that's something that you could possibly explore. All right, this is becoming much lengthier, so I'm just going to hit enter here and add the color. So recall that color is given by just color variable. And what I'm going to do here is I'm going to actually pop a color every time that I actually do a plot. So since we have a for loop, we can't really mention the entire list here as part of the color parameter. If you didn't have a for loop though, and then you're trying to somehow control various aspects of the plot using just like one plot function call, of course you can mention the entire list as this parameter. But recall that each execution of this scatter plot function is going to be for one class, so we want exactly one color. So I'm going to keep popping off colors as I keep assigning it to one type of class. So pop will remove uh, oh, oh, there we have it. I didn't define it as colors, so let me actually fix that. Let's not use the same variable name as the parameter. So there we have it. We now have like the three different classes as three different colors over here. Let's actually go ahead and add markers. So I'm going to add three different markers, which are circle for one type and caret for another, and I'm going to add V marker type for another. And then I'll have to mention marker as a parameter to my plot, and I'll have to again do markers dot pop of 0, which is going to pop the very first marker. Oh, I didn't actually define the variable as markers. There we have it. I am sure you can't actually see this, so I'm going to go back and fix the size here quickly. Let me actually make the size to be 16. Hopefully that will make that will change the plot. So I'm actually scrolling way down here to fix this particular plot. We'll see. Yeah, there we have it. I think I didn't run that previous cell properly. I'll make sure to go back and rerun everything. All right. As you can see, there is one other thing which is missing from this plot, right? It's the legend. I can't really look at this plot and say which is which type of class. So I'm going to actually go ahead and show you how to add a legend to the plot. So legend is going to be given by a parameter called label. So I'm going to go ahead and say label is going to be variety here. So label is going to be each of those classes, right? And the class name is given by the variable name variety. So if I do that, as you can see, it does add a legend to my plot, and now my plot is much more readable than before. One other aspect that you can spend some time on if you're interested is this legend box itself has a lot of settings. You can control the width, height, and the actual position using matplotlib parameters. So I'm leaving this at with the default location. You can play around with that if you're interested in that. A couple of quick Google searches will enable you to do that. All right, that's it for scatterplots topic. Hopefully, the concept of scatterplot is making sense to you. Once again, scatterplots are very efficient when you want to visualize relationship between different set of variables, and you can control a lot of aspects of your plot using many of the variable names in your data set. And what's new about scatterplot is we are plotting it from a data frame instead of plotting it from a series. All right. The next type of plot that we are going to be looking into is the line plot. So the line plot is going to be covering a series of examples. So let me see here. The first example that I want to cover is a very simple example where I have a series and I want to show you how to do a line plot with it. So I'm going to go ahead and define a series here. Let's say I have values 0, 100, 300, 200 and 400 just to have some sort of a variation. So let me go ahead and display S to make sure I have defined it correctly. There we have it. So adding a line plot is very simple. You can just mention s dot plot dot line, just like we did s dot plot dot bar. So as you can see, that does generate a line plot for you. Of course, we don't have the access, but we can vary that as we keep working on this example. Set those options as we keep working on this example. So the next thing that I'm going to show you is this particular line plot actually takes the default index for your series, right? Let's say that you want to actually control your index instead of having the default indices as like 0, 1, 2, 3, and 4. So you can mention index list when you create your series. You can just like add a list to a parameter called index, and let's say that I'm going to say my indices are going to be 0, 1, 20, 21, and 22 randomly, and let's see actually how the plot changes. So as you can see, as you vary the index values, your plot points get farther apart from each other, and the plot looks much different than before. All right, so one you know always one pitfall that students typically run into when they are learning about line plots is not having the x-axis actually sorted in a proper manner. So as you can see, these numbers are sorted, right? So let me show you what happens if I remove that one and add it to the end over here. So this is something that you need to always be aware of while doing line plot. As you can see, that garbled up the plot quite a bit, right? So you don't really want that. So what you want to do instead is have a sorted value for your x-axis. So I'm going to do that by using the sort underscore index function in a series. So you can just simply call sort underscore index on a series, which is going to sort the series based on index. And if you do that now, that should fix your plot over here. It's going to look different from before, but that's because our index 1 is now going to have a value of 400, right? Hopefully that makes sense. All right, that is all that I'm going to talk about with respect to this simple example. Let me actually move on to a proper example which uses the temperature data set which I was mentioning before. So if you go to today's code link, you'll have a file called snippets line and bar.txt. So as you can see, I have defined a hard-coded data frame in there, which I'm going to actually use for the next example. So we are going to visualize various low and high temperatures. So I'm going to go ahead and paste my data frame here, and let's take a look at what is there inside the data frame. As you can see, we have a lot of high and low temperatures. Clearly this is Fahrenheit because you have temperatures in 60. I'm talking about just day-to-day temperatures over here. Alright, let's actually create a line plot to visualize both the high and the low data for the temperature here. So you can simply say df.plot.line. That's actually going to help you visualize both of these variables in your data frame. One cool thing here is it automatically actually adds legend when you have like multiple lines in your line chart. But clearly there are a few things missing from this particular plot, right? For instance, there are no x-axis and y-axis labels. Let's fix that. Recall that you need to save the axis of plot into a variable. I typically call it ax, and then you can do set x label and set y label. So your x-axis label here is going to be I didn't actually tell you what the x-axis label here represents. We have like 12 entries for each of these lists for high and low. So each of those are going to represent 1 month's average temperature. So your x-axis is going to be month and y-axis is going to be temperature in Fahrenheit, right? So I'm going to just say degree F over here. All right. So let's rerun the plot. There we have it. We do have the axis now. So one other thing which is confusing in this plot is what is month 0, or like what is month 10 if you have a month 0. So let's actually go ahead and fix that. So in order to fix that, we need to add something which is called as the x-axis ticks, right? So I did mention as part of last lecture how you can control the rotation aspect of x label ticks, x tick label. So we are going to control both the location and the text this time. So recall that x tick labels actually needs you to pass a list of all the labels. So last time we just like took the list of labels from the series index column. So instead we are going to actually define our own custom list this time. So that's going to have 12 values, right? So I'm going to have Jan, Feb, March, April, May, and then June, and then I'm going to enter the rest in a new line. After that I have July, August, September, October, November, and December. Not that I doubt that you know the names of the month. I'm just saying it loud so that I am not missing those. All right. So let me go ahead and run that, and we'll see what's happening. Uh, that's weird, right? So we had 12 entries, but the axis actually, the X-tick labels only shows like 6 of them, right? So what went wrong here? So what went wrong here is there is another parameter which is called as just the x ticks itself, which controls where these small lines get added to your plot. So the default value for x ticks, let's actually see what is the value for x ticks by doing get x ticks. So there we have it. Oh, sorry, that is returning a function object. So I should have made the function call. there you have it. So the x ticks is given by another list, and as you can see, you only have ticks in positions 0 to 4 and like all the even positions, right? So what we want instead is we want this array to have values 0 through 12 to represent all of our months over here. So recall that you can use the range function to generate such a list. So instead of doing get x ticks, I'm going to say set x ticks. There we have it. Slightly, it's still a little bit cluttered, but we at least have the correct X-tick labels, right? So one other thing which is bothering me is that all of this return value from this X-ticks, set X-ticks function call is actually getting dumped on the screen. So you can either capture that into a variable to make that display go away, or as an alternate, what you could do is you can add the keyword none at the end of your cell, which is going to again make it go away. So instead of none, let's say if you have 1 plus 3, that's going to be the last thing that gets displayed when you run the cell, right? So if you have none, none is going to be the last thing that gets displayed in the cell. All right, there we have it. I'm going to actually take this example, and I'm going to make it a little bit better. So there are two options for you to make it better. So the first option is you can actually space out your x-axis by controlling figure size. Recall that figure size takes a tuple, and you can just mention the width and the height. So let's try 8 and 4. Hopefully I'm getting those correct. Yeah, there we have it. So you now have a better plot. Or the second option for you to fix this whole plot is going to be about let's actually get rid of the figure size. What you can do here is this is option 1. uh, what you can do here is you can recall that you can rotate the labels, rotate x-tick labels. So the parameter name for that is rotation, and it takes an angle, so I'm going to rotate it by 90 degree. There we have it. Now we have a better plot. All right. I do know that I'm probably going to exceed the 50-minute mark for this lecture, but I'm going to still cover complete this example. I'll actually resume the next lecture from the stock market example. So the final thing that I want to show you with respect to this example is I want to be able to convert the temperature into Celsius scale. So you can do a bunch of Google searches for this, but I can tell you how the conversion works. For the conversion, you need to actually reset the zero for both. So that's going to be done by df minus 32. Recall that Fahrenheit's 0 is given by 32, and Celsius 0 is Fahrenheit's 32, and then you want to divide that by range of all the possible temperature, which is going to be the boiling point, which is 212, and the freezing point, which is going to be 32, and you want to be able to multiply that by 100. So I'm going to capture this into a data frame called Celsius, and let me show you what is there in the Celsius data frame. So you can compare that what you had with the Fahrenheit. As you can see, hopefully those are the correct values. So I'm going to go ahead and copy my plot cell into the Celsius version over here, and instead of plotting df.plot.line, we want to be able to plot Celsius.plot.line, right? And then of course our the axis label to be should be fixed as degree Celsius instead of degree Fahrenheit. All right. One thing that you could possibly add to make this plot look better is you could actually add a freezing temperature line over here. So recall that you can very easily add a column to your data frame for freezing temperature by just saying Celsius of freezing is equal to 0. So let me actually display Celsius just to make sure we have the correct values. There we have it. So once you have a new column, you can very easily add the plot. You can very easily redo the plot by just like running the same code here. That's going to add the freezing point, and you can see which months of the year actually typically have below freezing temperatures. So this is actually really good graph, I would say, because April seems to have much better temperature than what we have currently. Hopefully, it will get better soon. All right. With that, I'll wrap up today's lecture. I'll actually go through the stock market example as part of the next lecture. Have a good weekend.